Welcome to a slow, beginner-friendly lesson on creating sets and testing membership in Python, made for absolute beginners. Sets begin. Today we slow down on sets, Python's collection for unique values. You met sets in the overview, curly braces, no duplicates. Now we go deeper. You will learn how to create a set, how to add and remove items, and how to test whether something belongs. The big idea today is membership. You ask, is this value inside the set? Python answers instantly. Sets feel strange because they have no order. By the end you will know when a set is the right tool. Unique values only. Recap from the overview. A set is a collection that holds unique items. You write it with curly braces, 1, 2, 3 inside. If you try to put the same value twice, Python silently keeps only one copy. Sets have no order. You cannot ask for the first item or the third. What you get instead is speed. Sets are built for one job above all, answering the question, does this value belong? Fast membership testing is the heart of what makes a set useful. From the overview, think of a set as a guest list. The same name cannot appear twice. Either you are on the list, or you are not. That simple either or is the whole shape of a set. Either in, or out. The simplest way to make a set is the literal form. Tags equals curly braces with Python, code, I inside, 3 strings separated by commas. Type of tags is set. Notice there is no colon inside. No key value pairs. Just values. That is how Python tells a set apart from a dictionary. A dict has colons, a set has only values. The order you see when Python prints the set is not guaranteed, never rely on it. Sets are about belonging, not position. The literal form. Here is a trap every beginner falls into at least once. To make an empty set, you must call set with parentheses, empty equals set. Type of empty is set. But if you write wrong equals empty curly braces, you do not get a set. You get a dictionary. Empty curly braces in Python always mean dictionary, not set. This is a hard rule. If you want an empty set, always spell it as set with parentheses. Memorize this one and you will save yourself confusing bugs later. Mind the trap. Sets become powerful when you build them from something else. Nums is a list with duplicates, 1, 2, 2, 3, 3, 3. Pass that list to set and Python gives you back a set with only the unique values, 1, 2, 3. The duplicates are gone. Wrap that result with list and you have a clean list with no repeats. This trick, list of set of something, is the standard way to remove duplicates from any list. We come back to it at the end of this lesson. Duplicates disappear, a set is less a shelf and more a sieve. You pour values in, and the duplicates fall away quietly. What remains is the pure collection of distinct things. Pour and filter. Here is what happens when you ask membership. You say, is Python in tags? Python does not scan the set item by item. Instead it computes a fixed fingerprint of the value, a hash, and checks one specific slot. Either the slot is filled, or it is not. One lookup, one answer, no matter how large the set grows. That is why sets feel instant even with thousands of items. This is the deep reason sets exist, to answer belonging in constant time. One lookup, one answer. The membership operator is the word in. Python in tags returns true because Python is one of the values. Java in tags returns false because Java is not there. That is the whole pattern, value, the word in, then the set. You get back a boolean, true or false. No loop, no scan, no counting. This single expression is the most common thing you do with a set. Anywhere you need to ask belongs to, reach for in. The membership word, the opposite form is not in. Java not in tags returns true, meaning Java is absent. This shape shows up constantly in conditions. If Java not in tags, then print missing. You will see this in real code. If username not in taken names, if file not in scene, if word not in stop words. Whenever you need to check that something is missing before acting, not in is your tool. Sets make that check essentially free, no matter how big the set grows. The opposite check, 2 everyday tools that work on sets. Len of tags gives 3. The number of unique items. And you can loop over a set with 4, for tag in tags, print tag. The order you see is not guaranteed, so do not depend on it. If you need sorted output, wrap with sorted. Sorted of tags gives a list in order. Sets are not about position in a row. They are about presence. Count with len, walk through with 4, and reach for sorted only when order matters. Count and walk. A set is not frozen. You grow it, you trim it. You add what belongs and remove what no longer fits. The collection breathes with your program. The collection breathes. To put a new value into a set, call add. Tags add I, now the set has 3 items. What if you add a value that is already there, like Python? Nothing changes. No error, no duplicate. The set silently keeps only one copy. That is the contract. A set never contains the same value twice. Add is safe to call many times. You will not get duplicates, you will not get an exception, you just get a set that already contains the value. Grow safely. Now removal. Tags remove code takes code out of the set. Works fine when the value is there. But if you try to remove a value that is not in the set, tags remove Java, Python raises key error. That is important. Remove is strict. It expects the value to exist. If it might not exist, you must either check within first, or use a safer method. We meet that safer method next. For now remember, remove raises when the value is missing. Strict removal. The safer method is discard. Tags discard code removes code if it is there. Tags discard Java, Java is not in the set, but no error is raised. Discard simply does nothing when the value is absent. That is the only difference between remove and discard. Remove complains, discard stays quiet. Use discard when you do not care whether the value was there in the first place. Use remove when a missing value signals a bug you want to hear about. Safe removal. Let us lock the difference. Remove raises key error if the value is missing. Discard never raises. Both take a value, not a position. Sets have no positions anyway. Neither method returns what was removed, they just modify the set in place. A simple rule for everyday code: when in doubt, reach for discard. Reserve remove for moments when a missing value means something has gone wrong and you want to know. Both are correct. They differ only in strictness. Strict versus safe. Sets support real set operations. The pipe character is union. A pipe B gives a brand new set with every value from either side, duplicates removed. 1, 2, 3 from A plus 3, 4, 5 from B. The 3 appears once because sets keep only unique items. You can also spell it as a dot union of B, same result. Union is the OR of sets, anything in either one ends up in the result. The OR of sets. The ampersand is intersection. A ampersand B gives only the values that exist in both. 1 is only in A, 2 is only in A, 3 is in both, 4 and 5 are only in B. The result is just 3, the one value shared. Spelled out, it is a dot intersection of B. Intersection is the end of sets, only items that belong to both survive into the result. The end of sets. The minus sign is difference. A minus B gives the values that are in A but not in B. 1 and 2 are in A, not in B, so they survive. 3 is in both, so it is removed. The result is 1 and 2. Spelled out, a dot difference of B. Order matters here, unlike union and intersection. A minus B is not the same as B minus A. Difference answers, what does A have that B does not? A minus B. Here is the everyday use of sets in real programs. Visits is a list with repeats, 1, 1, 2, 2, 2, 3. Pass it through set and back through list, and the duplicates collapse, 1, 2, 3. This is the standard Python idiom for removing duplicates from any list. You can also count distinct values. Len of set of visits gives 3. Whenever a list might contain repeats and you only care about the unique ones, list of set is your friend. List of set. A quick mention of frozen set. A regular set is changeable, you can add and remove. Sometimes you need a set that never changes, for caching, for using as a dictionary key, or for protecting shared data. Frozen set gives you that. Create it with frozen set of some iterable. Once made, you cannot add or remove, calling add raises attribute error. Frozen set is to set what tuple is to list. We do not go deep here, just know it exists. Set that does not change. Quick self-check. Can you create a set two ways, literal curly braces and the set function? Can you test membership with the in keyword? Can you explain why discard is safer than remove? Can you name the 3 set operators, pipe for union, ampersand for intersection, minus for difference? If any of these feels shaky, rewind the matching part. You do not need to memorize everything, just hold the shape of what sets are good at. Say each out loud. Here is the lesson in one breath. Sets hold unique values, duplicates disappear automatically. They are built for fast membership testing, value in set answers in constant time. You grow them with add and shrink them with remove or discard for safety, remove for strictness. And you combine them with 3 operators, pipe for union, ampersand for intersection, minus for difference. Whenever your problem is about belonging or uniqueness, a set is almost always the right choice. Sets in one breath. Your next step is practice. Open IPython and create a set. Add a value, remove it, discard something that is not there. Combine 2 sets with the pipe, ampersand, and minus operators. Try removing duplicates from a list using list of set. The ideas in this lesson only stick when your fingers type them. In the next lesson we slow down on tuples, Python's collection for fixed, unchangeable ordered values. The last piece of the 4 collection types. Practice, then tuples. Thanks for learning how to create sets and test membership. Next we meet tuples, Python's fixed collections. Onward to tuples.